guys, welcome to today's Leetcode Sunday contest. Today we'll be discussing problem number 3, and yeah, let's get started. So this problem states that we are given two arrays, skill and mana, and basically what we have to do is there are like n wizards, and each of these wizards can brew some potions, right? So for example, let's just start it from the table. So let's say they start brewing the potions at time 0, okay? And the first potion that they will be brewing is, let's say, this one, which has a mana of 5. So then the time that it takes for this wizard to brew the potion is 5 times 1, which is 5. So just add 5 to the start time. So then wizard 0 would be done brewing the potion by time 5, right? And then immediately passes that potion to wizard 1. So then the time that wizard 1 takes is 5 times 5, which is 25. But since it was handed over by wizard 0 at time 5, you add 5. So like 25 plus 5, 30. So the time at which wizard 1 would be done by is 30. Similarly for wizard 2, it is 5 into 10. So time that wizard 2 takes is 10 units. But since it was handed at 30, so 30 plus 10 is 40, right? And then similarly 5 into 4 is 20, 20 plus 40 is 60, right? And then you continue this process for all the potions, which is represented by this mana array in a similar manner, but there's a catch. So the catch is that if, let's say, we don't know the start time, let's say the start time is x over here, okay? And now then wizard 0 would be done brewing this potion by x plus 1, right? Because 1 into 1 is 1. So now this x plus 1 should be, so let's say the start time is x, right? So that means that wizard 0 picked this potion number 1 at x, but he was done with earlier potion by 5 units, right? So his x should be greater than or equal to 5. So similarly, it has a diagonal relationship. Let me illustrate that with a diagram. Okay. So let's say we are standing at potion number I, okay, which started at time xi. These are all your wizards: wizard 0, wizard 1, wizard 2, and so on. Okay. So this guy would do it at xi plus ai into, sorry, is my bad, a0 bi, right? This guy would pick it at xi plus a0 bi plus a1 bi, right? These are the finished times. a0 bi plus a1 bi plus a2 bi, right? And so on. This process continues. And let's say this was portion number I, and now this is portion number I plus 1, right? So let's say this guy picks it up at time xi plus 1. We know xi, but we don't know, we want to calculate xi plus 1. Okay. So then xi plus 1, so this guy would finish by xi plus 1 plus, again, it's the same equation, bi plus 1, okay, because we're brewing portion number bi plus 1. And again, xi plus 1 plus a0 bi plus 1 plus a1 bi plus 1, right? And so on. It continues like this. So now this guy would complete by this much time, but he picked the next portion at that time, at this time. So now we get an inequality over here. Xi plus 1 should be greater than or equal to xi plus a0 bi. And then wizard 0 finished it by this time, but wizard 1 finished the previous portion by this time, right? So this time should be greater than or equal to this time, right? Because this is the time at which wizard 0 hands over the potion to wizard 1, and this is the time at which wizard 1 becomes free to take on another potion. So basically we get an inequality of a diagonal relation. And then this should be greater than or equal to this. Then this should be greater than or equal to this, right? So if I generalize this, what I'll get is xi plus 1 plus sigma a, let's say L bi plus 1. L goes from 1 to, I think, a0, like how many wizards are there, right? Let's say we are looking at wizard k, right? So this is the time at which wizard k would be free with the I plus 1th potion. So this should be greater than or equal to xi plus the previous array, ALBI, AL equals to 1 till K plus 1, right? Because we are exploiting this diagonal relationship. So if this is wizard K, then this is wizard K plus 1, right? So his portions could go to, let's say wizard 2 is 0, 1, 2. So he can go to, like, I mean, let's put 0 here. It's a 0 base index. So 0, 1, 2, K is, let's say 1. So this K plus 1 will become 2, so 0, 0, 1, 2. And here it only goes till 0 and 1, right? And you get this inequality over here. Xi plus 1 should be getting equal to xi plus sigma ALBI minus sigma ALBI plus 1, right? L equal to 0 to K, L equal to 0 to, sorry, K plus 1, this is 0 to K, yeah. You find this inequality for all these equations and you take the maximum of them. That would be your optimal xi plus 1, right? Overall I mean, on the ith portion, right? Yeah, sorry, overall K. So because there are K wizards, right? 0, 1, 2, and K belongs in this range. So overall K, you do this inequality and take max. Because you know xi and you know this, right? That's why. And it would be optimal to take the max because it would cater to all the inequalities. It would satisfy all the inequalities basically, right? So yeah, and then you can calculate this easily using prefix sums, a pre-calculation of prefix sums, because bi is constant, and then it becomes like sigma al L equal to 0 to K plus 1. This is just a standard prefix sum of the over the A array, and then you just multiply by bi. And also you notice that if we have a DP kind of table, then this xi, basically what I'm saying is this one is already pre-calculated for you. This is just nothing but table of I, comma, because you are the ith row and then you are the K plus 1th wizard, right? Table of I, comma, K plus 1, right? So you don't even need to write this explicitly. You can just say there's this table of I, comma, K plus 1. It was completed previously, and we are interested in completing the I plus 1th iteration, right? So I'll just jump to the code now. That's what I'm doing here. Just getting a table up and calculating the prefix sums. This basically this prefix sum, right? Because you still need to calculate this one, right? And let's say I'm just pre-calculating the 0th portion, because it would be just it would just start from time 0, right? So prefix of I, like sum of all the skills of the wizards till the ith wizard into the time it takes to brew the mana of 0, like the first portion, right? So let's say the current time is table of I minus 1, 0, right? Because I minus 1, 0 is basically nothing but this guy is table of I 0, right? I am like doing a backward DP, so it's like I and I minus 1, can calculate I from I minus 1, right? It's like table of I minus 1, 0, right? So that's your current time, because xi, this is your initial condition, right? That's why. And then I'm just taking a max of the C time, like going to the previous row, but a wizard greater than the previous, like the current, minus this one, this equation, AL BI plus 1, right? Yeah, so mana of the trying to brew the ith portion, and sum of skills of all wizards till jth portion. So you just take the maximum of these, and then you fill the table of ij, okay? Because you still need to like be ready for the next iteration. So table of ij is just the current time plus the skills of the wizard till the jth wizard into the time it takes to brew the ith portion, right? And current time you calculate from the above table. And yeah, you just return the time it takes to brew all the portions. That is the end, the last entry of the table. So yeah, thanks for watching. Bye.